Hello everyone, we will be discussing the capital budgeting techniques through this series of video. Here I have started with net present value method. The net present value method is one of the technique of capital budgeting in which we try to evaluate the different projects. As we know, the net present value can be calculated by subtracting the project's initial cash outflow from the present value of the revenue that is generated from the investment. As you can see from the formula that is over here, the following formula we use to determine the NPV. NPV is equal to I, that is initial investment, plus summation of J from 1 to N, cash flow J divided by 1 plus I raised to the power J, where J is number of years and I is interest rate. We will be doing this valuation using an example that I have taken. Here it is the example. Assume that project X costs rupees 2500 now and is expected to generate year-end cash inflows of 900 rupees, 800 rupees, 700 rupees, 600 and 500 in years 1 through 5. The opportunity cost of capital may be assumed to be 10%, and we have to determine the net present value. Using this information, we can create one table. As you can see over here, in the first column I have mentioned year, and as the number of years are 5, so from 0 to 5. The second column consists of cash flow that is given in the question, and the discount rate, we have to discount the cash flow. So starting off with by entering the cash inflows, as you can see in the question, it is mentioned that the capital outflow is 2500 rupees. In the first year, inflow is 900, second year 800, third year 700, fourth year 600, fifth year 500. So similarly, we have to plug in all the values in the relevant year. Now we have to discount the cash outflow using an interest rate of 10%. So discount rate will be equal to 1 upon 1.1 raised to the power 0. Here we have taken 0 because this happens at the year 0. So it would be raised to the power the year in which it occurs. So it is 1 upon 1.1 raised to the power 0, and it comes out to be 1. Now we have to multiply minus 2500 by the discount rate. So we will get 2500 minus 2500 multiplied by 1 comes out to be minus 2500. Similarly, in the second year, the discount rate would be 1 upon 1.1 raised to the power 1. Again, since it happens in the first year, so raised to the power 1. On dividing 1 by 1.1, we get 0.909. Now again, multiplying the cash flow, that is 900 by 909, we get 818.18. Similarly, in the second year, we can see it is 1 upon 1.1 raised to the power 2, since it happens in the second year. So it comes out to be 0.826. Now we have to multiply 800 by 826, we get 661.16. Similarly, for the third year, the discount rate is 1 upon 1.1 raised to the power 3, that comes out to be 0.751. Multiply 700 by 0.751, we get 525.92, as you can see over here. So in next year, 1 divided by 1.1 raised to the power 4, it comes out to be 0.683. Now multiply 600 by 683, we get 409.8. Similarly, for the fifth year, it comes out to be 310.46. Now, for calculating the net present value, we are supposed to add all the values that is here in the last column, that is minus 2500 plus 818.18 plus 616.16 plus 525.92 plus 409.8 plus 310.46, and on adding all these values we get approximately 225 rupees. And as you can see, the net present value is positive, therefore this project can be selected. Moving ahead, I have taken another example, and here as you can see straightforward, I have just plugged in all the values. The project has to be evaluated, and it has an initial cash outflow of -1000, and first year revenue is 600, second year revenue is 200, third year revenue is 200, and last year, that is in the fourth year, the revenue is 1000. Here the discount rate is 12%. We have to determine the net present value. So as we have done in the previous case, similarly we have to first of all determine the discount rate. So as you can see, the discount rate is 12%. So here we have divided 1 by 1 plus 0.12 raised to power 0, because it is in the year 0. So it comes out to be 1, and then multiplying the discount rate by cash flow, we get -1000 multiplied by 1, it comes out to be -1000. Similarly, we have to calculate it for first year, that is 1 divided by 1.12 raised to power 1, it comes out to be 0.8929. Again multiplying 600 by 0.8929, we get 535.71, as you can see over here. Similarly, in the second year, the discount rate comes out to be 0.7972. Multiplying 200 by 0.7972, we get 159.44. Likewise, you can calculate for the remaining years, and we get the value of 635.51. Now, in order to calculate the net present value, we are required to add all these values, that is -1000 plus 535.71 plus 159.44 plus 142.36 plus 635.51, and on adding these values we get 473.02. So the net present value is 473.02. Now you can even use the Excel function to determine the net present value. As you can see over here, we are having the years, and we are just required to plug in the cash flows, and in the Excel function we are supposed to write equal to sign, then NPV within parenthesis, the required rate whatsoever it is mentioned, 10%. Then we are supposed to select from first year to the fifth year, and then close the parenthesis plus the outflow, that is B3. So you will get an NPV of 1910.26. So we can use even Excel function to determine the net present value like this way. Now, what are the decision rule for NPV? When NPV is less than 0, that is when NPV is negative, reject the project. When NPV is equal to 0, so you must be indifferent, that is you may select it or you may reject it. Now when NPV is greater than 0, then we must accept the project. So like this we can solve for the NPV problems. I feel these two problems would be helpful to you in solving the net present value. Now moving ahead, now there is another technique which is very simple, that is payback period, because it does not consider the time value of money. So it is one of the simplest technique of capital budgeting methods. Here I have taken one example. The example is something like this one. Assume that project X cost rupees 10,000 now and is expected to generate year-end cash inflow of rupees 2,500, rupees 4,000, rupees 5,500, rupees 7,000 and rupees 8,500 in years 1 through 5. The opportunity cost of the capital may be assumed to be 10%. Determine the payback period. So here we are required to determine the payback period. So first of all we have to plug in the cash flow into the years. So in year 0, and capital outflow of 10,000 rupees is mentioned, so it is minus 10,000 at the year 0. Now in cumulative cash flow we will be adding straightforward. Now minus 10,000 we will add, so it will come out to be minus 10,000. Now in year 1 there is an inflow of rupees 2,500. Now this 2500 will get added to the minus 10,000, that is the last column value. Minus 10,000 plus 2500 will come out to be minus 7,500. Similarly, in the second year, there is a cash inflow of 4,000 rupees. Now, this cash inflow will get added to 7,500. So, minus 7,500 plus 4,000, it comes out to be 3,000 minus 3,500. In the year 3, there is a cash inflow of 5,500 rupees. Now, this 55 will get added to minus 3,500, so we will get a positive 2,000, that is 2,000 rupees. Now in next year we are having an inflow of 7,000. Now 2,000 and 7,000 comes out to be 9,000 rupees. Last year we are having an inflow of 8,500, so this will also get added to 9,000. So 9,000 plus 8,500 comes out to be 17,500. Now as you can see here, I have highlighted two values, that is minus 3,500 and 5,500. By payback period, we mean that in what time we will be able to recover this 10,000 rupees that we had invested into the project. Sorry. In what time period we will be able to recover our investment. So our investment is 10,000 rupees, and as you can see in the year 2, the total recovery is 6,500 rupees, and a total 3,500 rupees is still to be recovered. And in the next year the cash inflow is of 5,500 rupees. Therefore, in the third year, that is somewhere in between second year and third year, we will be able to recover this 10,000 rupees that we had invested. So this is termed as payback period. Now how to calculate the payback period? So it is very simple, just we are required to sorry, we are just required to write this formula. As you can see, in the year 2, the total amount which has to be recovered is 3,500 rupees. So it is 2, it would be greater than 2, so 2 plus the amount which has to be recovered, that is 3,500 rupees, and next year's income, that is 5,500. So 3,500 has to be recovered, is yet to be recovered, and 5,500 rupees is the income of the next year. Therefore 2 plus 3,500 divided by 5,500, it comes out to be 2 plus 0.636. This means that we will be able to recover the amount, that is 10,000 rupees, in 2.64 years. Like this we can calculate the payback period. Now moving ahead to the discounted payback period, discounted payback period. Here I have taken the same example which we had considered in the payback method. The only difference between payback method and discounted payback method is that under discounted payback method we consider the time value of money, that is the value of money decreases with the passage of time. So here we are required to calculate the discounted value of the cash flow. So as all the values is known to us, that we are required to invest 10,000 rupees. So minus 10,000 in first year, inflow of 2,500, second year 4,000, third year 5,500, fourth year 7,000, and last year 8,500 rupees. Here the discount rate is 10%, so we are required to calculate the discount rate first. So calculating the discount rate, again using the same formula as we have done in case of NPV, 1 divided by 1.1 raised to power 0, because it occurs in the year 0. So raised to power 0, it comes out to be 1. Now we are required to multiply 10,000 by 1. Multiplying minus 10,000 by 1, we get minus 10,000. So minus 10,000 will be the cash flow, discounted cash flow at the year 0. Now this will go straight forward to the cumulative cash flow, that is minus 10,000. Now in year 1, the cash inflow of 2,500 rupees is there, so we are required to discount this value. So the discount factor would be 1 divided by 1.1 raised to the power 1, because this happens in the year 1. Now multiplying 2500 by 0.909, we get 2272.73. Now add this 2272.73 to the cumulative cash flow of year 0, that is 10,000 minus 10,000. Now when you will add this amount, you will get minus 7277.27. What, how we have calculated? Minus 10,000 plus 2272.73. So you will get minus 7277.27. Similarly, in the third year, calculate the discount rate, then multiply the cash flow, that is 4,000, by the discount rate. You will get 3,305 rupees 79 paise. Now add this to the cumulative cash flow of year 1, that is minus 7277.27 plus 3,305.79. So on adding these two values, you will get minus 4,421 rupees 49 paise. Similarly, calculating the discount rate for year 3 and multiplying the discount factor by the cash flow, that is 5,500 multiplied by 0.751, we get 4,132.23. Now add 4,421.49 to 4,132.23, we get minus 289.26. Similarly, calculating the discount factor for year 4 and the discounted value, that is 4,781.09, add to the cumulative cash flow, we get 4,491.84. Similarly, we can calculate for the last year as well. So sorry, so we can see we are getting a, again here I have marked the cumulative cash flow at one place in the green shade and the discounted cash flow into red shade. Now how to calculate the discounted value? So the discounted payback period can be calculated as follows. As you can see that in year 3 the cumulative cash flow is minus 289.26, and as in year 4 it is positive, that is in between third year and fourth year we have recovered the 10,000 rupees that we had invested. So it would be greater than 3 but less than 4. So 3 plus, now what amount we have to recover? 289.26. So it will go to the numerator, and in the next year the income is 4,781.09. So amount that has to be recovered divided by the income of the next year, so it comes out to be 0.06. So the discounted payback period at a rate of 10%, we are getting 3.06 years. So like this you can calculate the discounted payback period. Sorry. Now in the next session we will be discussing the other techniques of the capital budgeting. If you are having any query, you can contact with me through email. Thank you.